Alright, so in this video, we're going to be going over the problem of the day, which is cheat code problem number 3372, maximize the number of target nodes after connecting trees 1. Alright, so this is a medium level problem and we're going to solve this. So firstly, let me just go through the problem statement. So there exist two undirected trees with n and m nodes with distinct labels in range 0 to n-1 and 0 to n-1 respectively. So you are given two integer arrays, 2D integer arrays, edges 1 and edges 2 of lengths n-1, m-1 respectively, where edges 1 of I is equal to ai bi, ai comma bi, indicates that there is an edge between nodes ai bi and first in the first tree and edges 2i. So the standard basically the adjacency list, sorry, the edges format of representation for the graph or a tree, basically, since you're considering trees here. So you're also given an integer k. Node u is target to node v if the number of edges on the path from u to v is less than or equal to k. Note that a node is always target to itself. So this is an important point here, and I'll show you on sketchpad. So yeah, on this basically I'll be noting down the important points. So right now you see node u is target to node v if the number of edges on the path from u to v is less than or equal to k. Note the node is always target to itself. So let me just note this down. So let me show you here. If let me just write it here in text. So basically, u is target to v if what is it written? If the number of edges on path from u to v is less than or equal to k. If number of edges uh, between u to v is it need not be an directed edge is less than equal to k, right? Less than or equal to k. So this is the thing we've got right now. Okay, so this is the information we got till now while reading the problem. Now what we need to do is return an array of n integers answer, where answer of I is the maximum possible number of nodes target to node I of the first tree if you have to connect one node from the first tree to another node in the second tree. So in the problem, basically, we have two trees, first tree 1 and the second tree, which is tree 2. So what we need to do is we basically need to return the maximum possible number of targets from node I of the first tree, which will get connected to any node of the second tree, and we need to return the maximum number of nodes target that can be connected, right? So note that the queries are independent from each other. That is, from every queue you will remove the added edge before proceeding to the next query. So basically what we need to do here is, let me show you. Let us go through the example first so that you get the understanding of the question. So let us copy this, edges 1, edges 2, right? So let me copy this and let me have another text. So okay, so this is basically our graph, first, sorry, the tree 1 and tree 2 edges. So let me just make this for you guys, right? So basically what we have, edges 1 is 0 1. Let me just shorten this. Wait a second. How do we select this? Yeah, this is select. Let me just uh, take this here. So in this video, we're going to be talking about the approach that we'll be forming here, and the coding part we'll plan, okay, in a later video. So firstly, we have 0, then 1. 0 is connected to 1. 0 is also connected to 2. So let me draw 2. Then 2 is connected to 3. So it's 3. And 2 is also connected to 4. Right. So this is, sorry for the bad drawing, but like I'm using the mouse. So please, apologies for that. But I'll show you for edges 2 now. 0, 1. 0 connected to 2 as well. Then 0 connected to 3 as well. So let me draw 3 here. Let me just make it a bit neater. I'm trying. 2 is connected to 7. 1 is connected to 4. Okay. 1 is connected to 4. 4 is connected to 5. And 4 is also connected to 6. Alright. So basically, this is the graph that has been formed, or the trees that have been formed. So our aim is to basically get the maximum possible number of nodes from each node of basically maximum number of targets from each node of tree 1 after connecting every node with one node from tree 2, so as to maximize the number of possible targets for that particular node. All right, so this is basically what we need to do. So basically I'll show you. What we need is, for example, if you're considering the node 0, this is the first node that we're considering, so it is I is equal to 0 for our 0th element. Basically our answer would be stored in the form of a list or an array or vector in CPP terms. So 0 1 2 3 4 indices I've mentioned. So for 0th index, we see that how many targets can be achieved from this. So by definition, in the problem it was given, u is target to v if number of edges between u to v is less than or equal to k, and k in our problem statement here, k is given as 2. So if k is 2, sorry for this, basically what we'll do is remind ourselves that we're starting from 0, right? So we need to count the number of edges which are less than or equal to 2, right? So since k is equal to 2, we see that obviously 0 would be considered because 0 is the node itself. So we can reach this, and it is at a distance of 0 from itself, so we consider this, so that's 1. Then we see that there is only one edge, so the count is one edge, so this is also added. Then this would also be added, and then nodes 3 and 4 would also be added because they're also connected within distance of 2, right? So this is distance 1, and the second step is also second edge, that is also considered. So that makes it basically how many do we have here from this T1 without connecting right now. We have not connected the T2, so we're just considering by connecting T1. So we see that it's basically 5 nodes that have that can be a target, right? So maximum number of nodes target to node I. So these are the maximum number of nodes target to I without being connected to T2 right now. Now what we do is basically, now the main problem statement comes that what we need to do is basically we have the possibility of what is given here to connect these two trees. So if this is the part where the connection problem is confused. So if you have to connect one node from the first tree to another node in the second tree, what would be the maximum possible number of nodes target to node I of the first tree, right? So now we need to think in a way that if we can connect for this 0, what are the possibilities of connecting? There would be 1, 2, 3, 4, 5, 6, 7, 8 possibilities of connecting one edge from T1 to T2 from node 0. So we have to consider all the possibilities and then check for the maximum, what will be the maximum number of targets possible, right? So in this, if you let us say we connect to 1, right? For example, hypothetically, we're connecting to 1. Now basically, this is the joint tree, and in this tree, we have to check if our what is the number of additions to our uh, targets from node 0. So you can see that these 5 were already there. Now since this edge has been introduced, we can see that we can also reach node 1 from the other tree. So basically this would also be considered. Then we can see that this is at a distance of 1. So since k is equal to 2, we can also go another edge more ahead of this. So we see that 1 is connected to 0 of the tree 2 and 4 of the tree 2. So we can consider these two as well. But we can't go further than that because then it would require us to have k is equal to 3, right? So basically 1, 2, 3 nodes would be added here. But this is the hypothetical situation where we are just considering all the possibilities by connecting each node to each node from 0 to the T2. So basically we need to just check, right? So if you think about it, you realize that uh, we don't need to connect this to 1, since this would be giving not the maximum or the optimal solution that we need. So since this is not the maximum one, what we need to do is we need to check for the maximum one. So what would that be? Obviously, we would have to consider the edge, the node from T2, which has the maximum number of maximum degree, right? So which has the maximum number of connections. So you can see this node 0 has the maximum number of connections here, and also 4 here has the maximum number of degree, that is 3. So basically, since k is equal to 2, if you connect 0 with 0 of T2, or if you connect 0 with 4 of T2, that's why I've made a dash line. So you can choose either of them. You will realize that not only you're getting an additional 3, but also another one target node, because you now have a degree of 3, which was not in the case of when we were considering the node 1, because then we only had a degree of 2. So that is why we have to choose the node with the maximum degree from T2. So I hope you're clear with the logic. So you can see, let us say we have a res2 variable, a res2 vector, where we'll be storing all the uh, number of 1, 2, 3, 4, 5, 6, 7, right? Uh, yeah. So basically 0, 1, 2. Yeah. So basically you can see that what I'm aiming to do here is we can calculate for k minus 1. For k minus 1, we can apply, since we're traversing the trees, so we would obviously need to traverse it either in DFS fashion or BFS fashion. So it's your choice. Let us say I'm considering DFS. So I would take DFS of k minus 1 for connecting this tree 2. So this is basically tree 2 I'm passing. In the question, it's given edges 2, so we'll consider that. But for simplicity's sake, I'm just writing T2, which is T2 here. This is the same, right? So what this does, what this outputs is the number of targets that can be achieved once we have connected our node I from T1 to any node of T2. So for all these possibilities, we'll check. So there are 8 possibilities as I suggested. So for this, you can see how many more new possibilities are occurring since we are considering k minus 1. So you see the node itself along with 3 other nodes would be happening. So that would be 4, right? For 0 would be 4. Now for 1, how many new nodes would be considered as target when connecting the ith node from T1? That would be 1, 2, and 3. Since we can go only a distance of 1 from the tree 2 because we've already considered because we're considering k minus 1, right? So k is equal to 1 would be the correct number of edges that we can traverse in the tree 2, right? So that would be 3 here. Similarly for 4 would be 4, so I'll fill 4 up. For the node 2, we can see we have 3 possibilities if we're connecting 0 to 2. If we're connecting 0 to 3, we can see that we have 3 as the possibility and 0, so that would be only 2 possibilities. Now if we're connecting 5, again 2 possibilities. For 6, we'll have again 2 possibilities, that is 6 and 4. For 7, we can have 7 and 2 as a possibility. So this is basically the vector for storing the possibilities, and from this res2 vector, we will be getting the max element. So the max element from them will be chosen as the uh, addition that would be added into the tree 1. So basically, we'll add the max element to this to all the values of this so as to get to our final answer, right? So for 0, so basically this what this explanation is basically you won't understand from this explanation, so that's why I had to draw and show you. That's why this video got a bit long. So let me just complete this explanation and we'll do the coding part in our next video. So basically for I is equal to 0, as you can see, we have also already done this. Now one thing you realize that from from all the other nodes, their values basically from T1 the values would change, but the rest two, since it is the same, this T2 would remain constant. So the max element that we receive would be constant. So that is 4 here. So once we achieve this, there's no need for recalculating rest 2 or anything because T2 is now constant, and we calculate the same for, let us say, for node 1, I is equal to 1. So we'll basically check, this is the node, yes, this is the node, yes, at k is equal to 2 distance, yes. So basically 3 nodes here. So we consider this in T1, right? So this T1, this is basically achieved from DFS of T1 comma k, since we are considering till for k distance, right? There's 2 distance, and once we connect 0 or 4, as I said, this is constant, so the addition would also be constant, so plus 4 in all the cases. So let me just complete for 2. You can see that we have 2, 0, 3, 4, and 1 as well, because this is 1 is at a distance of 2 and all the others are at a distance of 1. And when we include itself, the distance would obviously be 0, so that will also be considered. So we have 5 again here. For 3, we have 2, 4, and 0, so that would be, and 3 itself would be 4 as the count, and 4. But this is not a final answer. We'll just add the max element for all these, plus 4 for all these, and then we reach our final answer, which is 9. We're adding all these, all the all of them to T1 array. So that is res 1. So 9, 7, and plus 4 to this, again 9, then 8, and 8. So this is our final array or list. So you can check here as well that this is our final array 97988, right? So this is our answer, and for this this also you can see by connecting. And yeah, so hopefully you've understood the crux of the problem and the whole explanation of what we're aiming to do. And in the next video we'll be moving on to the coding part.